we'd probably need to pad it with 1,000 hex bytes. So I'll quickly do that. And I'll just add 1,000. Okay, so that basically just padded the file with a lot of space for me to work in. I'll save it, and hopefully this file should regain functionality. Ah. Yeah, blame Microsoft. Chris or Microsoft, one of the two. No, it's my laptop. It'll probably take a few seconds just to pull out of this. Okay, so there you go. It's functioning. It's probably open port 99 and waiting for all the evil hackers to telnet back into my machine. Okay? Okay, so what we did until now doesn't really help us in avoiding antivirus software, because we haven't really changed anything apart from just adding padding to the end of the file. So it's still identified as malware. But let's start our Oli games now and see what we can actually do in order to encode and decode this file in real time. So we'll open wonderful, wonderful Oli. Actually, I should be using Immunity Debugger because it's like, you know, light years ahead. But I find that Oli has a much smaller footprint, and for simple demonstrations, I still prefer using it. But if you want to do this, you really should download Immunity Debugger. It's light years ahead. Okay. So we open our malicious file, and Oli takes us straight to the entry point of the file. Okay, and these are basically the first instructions to be executed by the file. And what we want to do is hijack the execution flow and redirect it to an area where we can actually inject our stub. So just to be organized, I'll copy-paste this stuff which I'll be overwriting, and I'll put it in a nice notepad file, in a text file. Okay, we'll be using these addresses and these commands later on for reference. And what I'll say, what I'll look for now is that iData section which we enlarged. And you can actually see that these are all the bytes that we added, yeah? So if I were to choose, say, this address to inject my stub, that actually looks good. So let's make a note of this. Let's say code cave starts at, and what is that? 0041, what was it? 41 2800. Thank you. Yeah, that looks good. And let's start our hijack. So I'll go back to the beginning of the file. This is, once again, the entry point. And I'll overwrite this stuff with a jump directly to our new code cave. Okay, so I'll overwrite this, and I'll say, please jump to my code cave. And when I do this, you'll actually see that these first few instructions will be overwritten. Okay, let's just look at that, and you'll see that I overwrote these three instructions. So I'll save this change to file. You can do that through Oli. I always get confused here. Save. No. Save to, yeah, there you go. So I'll save that change, and we'll save this to a new file called -1. So let's open this new file in Oli and see what happens. All right, so once again, we're taken to the original entry point. We can see that our command was rewritten. And if I single-step this command, I'm taken straight to my code cave. Yeah, that wonderful place where I'll be doing all my evil stuff. So now that I'm here, what I want to do is I want to add my XOR loop, which will decode and encode the file each time it's executed. So I've actually got in the presentation, let me show you this. It's much easier than it seems. All right, so this is our loop. And basically what we're going to be doing is we'll be encoding part of our file. I'll be encoding just the data section of our file, because that's enough for this demonstration. And I'll be starting the encoding routine from a specific address, which we'll identify in a few seconds. And I'll be moving that address to EAX. I'll be XORing the contents of EAX, and then increasing EAX, and then comparing it to the end address that we want to encode and decode at the end. If that address has not been reached, then the loop just goes back to the XOR routine, and it continues that way until we actually reach the end of the section that we want to encode and decode. So that's basically the loop. So let's quickly do that. I'll literally copy-paste this information. Perhaps before I do that, I'll just identify what sections I want to encode and decode in the file. So let's go back. And my guess is if we start encoding our file from this address, and we run all the way down the data section, this looks like a good ending point. Then we should be okay. All right. So I'll grab my encoder, which I've already got here. I'll just make sure that the address is okay, so it'll be easy for me to copy and paste, because we're under serious time restrictions. Is this loop clear to everyone? I mean, assembly looks scary until you actually try it. All right. So we've jumped. Let me just restart this so I don't make any mistakes. And this is our code cave, so I'll just start pasting in my encoder. No, I think I made a mistake, actually. Good thing that I caught this. So it's going to move that to that address, XOR it, increase it, compare it. And if it's not equal, we actually want to jump back to the XOR routine, which is at 41:28:05. All right. So this is the routine that's going to encode and decode the whole file. And once the whole file is encoded, what we want to do is we want to reintroduce the commands that we overwrote with our initial hijack. So let's quickly do that. And then once we've introduced these instructions, what we want to do is jump back to the original place where we left off after our hijack. So that should be this address. So we'll just jump there. And I hope I haven't made any mistakes, because it will be very embarrassing if I have. And we'll save this to disk. And let's see this file run under Oli now. Okay, so once again, our execution flow is hijacked by the initial jump. We've got our encoder scheme here. Now, let's take a quick look at how this works. I'll actually go to this address. And this is basically the binary contents